Whereas we are back for the second part of the video for 1-6 week 8. So now we're looking at another irrational number within an inequality. So we have the square root of 10 plus a 2. Is that more than, less than, or equal to a 10 plus a square root of 2? So what we have to do is approximate these imperfect squares between 10 and 2 square rooted. All right, so the first thing we have to do is we're going to start with this value of the square root of 10. And again, when we do that, we have to look for what is the perfect square group, right? So what is the perfect square group? So again, we have to remember square root of 1, okay, equals 1, okay, and then we get 4, the square root of 4 equals 2. The next perfect square is 9. That gets me 3 because 3 times itself is 9. 16. Square root of 16 is 4, or 4 times itself is 16. And I'll stop at 25. You can go to 36 and so on. So these are your perfect squares, right? So where would the square root of 10 fall in, right? Where would that fall in? So of course it's going to be somewhere in here because it's more than a 9, right? And it's less than 10. But is it closer to a 9 or is it closer to a 16? Right? So it's closer to a 9, right? 10 is only 1 away from that. So that's kind of our baseline thinking, right? So I'll go back here. And so we're going to take that 10 and we're going to estimate that it's between 3 and 4 because the square root of 9 is 3, but it's less than 4. So we're then going to just turn that into 3.5. Okay? That's not the best estimate, but it's good enough. So we're going to use 3.5 now as the estimate equivalent of the square root of 10. Now we're going to do the same thing with the square root of 2. And we did this in the prior video. The square root of 2 is not 1, right? Because 1 times 1 is 2. 1 times 1 is 1. And it's not 2 because 2 times 2 is 4. 2 squared is 4. So it has to be between these two. So we're just going to go ahead and place the 1.5 as the rough equivalent for this square root of 2. Just like we did with the 3.5 would go in here. Now once we've simplified those square roots, we now can do the next operation, which happens to be addition. So when we add this on the left side of the inequality, we get 5.5, and on the right side, we get 11.5. So therefore, the 11.5 is greater than, or the square root of 10 plus 2 is less than 10 added to the square root of 2. I'm hoping this is making some sense here. So now we get into example 3. You can see some answers here, right? And I would like to focus on 2b, okay? And so 2b right here, let me just copy this, okay? So I have some more room to operate, okay? So again, the first thing I have to do, is I've got to negotiate what these square roots are, okay? So my perfect square was 16, square root of 16, square root of 9. Okay, so it's between those, right? Because those get me perfect squares. And the square root of 9 is 3, and the square root of 16 is 4. Therefore, my answer is going to be between 3 and 4, and I'm just going to put 3.5 there. That's good for now. Okay? And then on this side, again, my square root of 6, okay? It's less than the square root of 9, but it's more than the square root of 4. So if the perfect square of the square root of 4 is 2, and the square root of 9 is 3, so it's going to be somewhere in between. So I'm going to just go ahead and put this value in at 2.5. And then I'm going to combine the terms on each side of the equation. And 3.5 plus 6, I believe, gets me 9.5. And then 12 plus this 2.5 gets me 14.5. And therefore, obviously, we know that 14.5 is greater than 9.5. All right, so we just did another example up here. So let's go ahead and look at some of these questions that you might have. So how do you express all the numbers so that you can compare them? You can write fractions as decimals and then write all those irrational numbers as decimals. You want to turn them all to the same thing. So fractions to decimals or decimals to fractions, we need to have those in the same form. Okay, so it's really important. Okay, it's really important. So again, we're going to order these three things, right? I'm going to just kind of go ahead and again do what I did last time. So we're going to order these from least to greatest. Now they're all in different forms. What I do know is that 1.5 and pi are basically in decimal form because pi we can abbreviate in middle school as an irrational number that can be rounded to 3.14. And then we already have 1.5. So right now we know that 1.5, we just don't know where the square root of 3 is. So we could have space anywhere. So 3.14. And so now we know that where would then our last one is the square root of 3. We have to simplify this. And we're going to estimate, and where would it fit? Would it be the smallest number? Would it be the medium number? Or would it be the greatest number? And so mathematicians like you should be thinking, okay, let me think logically before. Now we know it's not going to be the largest number because it can't be greater than 3. The square root of 9 itself is 3, so it's definitely not. So is it the smallest number or is it the middle number? So that's a great way to start, right? And remember, what are we doing? We're thinking of perfect squares. Perfect squares. So these are our perfect squares. The square root of 3 is not perfect. It's somewhere between these digits. And then we just have to remember how to simplify these. And the square root of 1 is 1, and the square root of 4 is 2. So it's somewhere between 1 and 2. And so I'm going to just estimate in my mind that it's 1.5, but then here I'm not sure. So I've got to validate on this one. So what I'm going to do is I'm going to start with 1.5 squared and see what that gets me, because they might be the same value. So 1.5 squared, or 1.5 times itself 2 times, is 2.25. So that's too much. So this number has to be less than 1.5. Now, just to validate, I'm going to do 1.4 times 1.4 and see if we're closer. And that gets me 1.96. So this, if anything, it just proves that the square root of 3 has to be less than 1.5. Then our second greatest number is the 1.5, and our greatest value is pi, because we should know in 8th grade that pi is equal to 3.14. So after all of that, I'm hoping that makes sense on how you can, oops, I need to go backwards, not forwards, on how we can get these numbers. What I want you to do is you can copy this, and I want you to think about it, and for the video's sake, I'm just going to allow you to do that and pause it, and then I'm going to jump in and finish up with 3A and 3B. All right, so hopefully you pause, and we're gonna skip down to the try this. And so now we're going to order these numbers of the square root of 5, a decimal number of 2.5, and a square root of 3. Well, first off, you probably know, just mathematically, that the square root of 3 has got to be less than the square root of 5. So where does 2.5 fit in compared to those? We've already done the work with these numbers in our notes. So the square root of 3 is about 1.6 something, and the square root of 5 is actually a little bit more than that 2.5, and so that's going to be our order. So what you would want to do is turn these two square roots into estimated decimal numbers to compare them. For 3b, now we have an extra step. So I'm going to go ahead and copy this real quick. do the same thing I did before, and I'm going to put these in order. Okay? So these are three different things. So 10 is already simplified, so I'm good with 10. And I'm going to just start with the square root of 75, right? So square root of 75. So I know a perfect square is 81 is 9. So this number, the square root of 75, is going to be less than 9. So for now, I'm just going to put something like, I don't know, 8.7. And we'll see if that will work. Now we're going to go to this value, which is going to be pi squared. Okay? So in order for us to do that, we're going to multiply pi to a power of 2, or square it. Right? So I'm going to use my calculator to validate. So 3.14, and we're going to abbreviate that ratio for pi, and that gets us to 9.8565. 9.856, and I'm going to stop there. So now I know that this value is less than 10, and I know this has to be less than 9, so I don't have to do any more investigation. You could prove it in your calculators, but now that we have this, we should know that the least value is the square root of 75. It's about 8.6 something. The second greatest value is pi squared, which got us to a little bit over 9. And then the 10 is the greatest number. So in closing, remember, you can estimate irrational numbers by using square roots of perfect squares as a reference, like square root of 4 is equal to 2, and the square root of 100 equals 10. It's important to know your square roots to estimate, right? Your perfect squares, I should say. Find the two perfect squares, and then the irrational numbers falls between them. And then refine your estimate, like going from 1.4 to 1.45, and so on. To compare and order those rational numbers, convert them all to decimal numbers or fractions with common denominators. So that's what I have today. Your final code was before. The last video was your birthday. But now your code, like for me, is going to be 0829. But to validate both videos, I have to find out what the actual day you were born on. So for me, I know I was born on a Wednesday. Exciting. So for you, you might have been born on a Tuesday. And that code would go on the top of your homework up here. Don't forget to, if you can, would you write 1-6 on your math? And would you include your name at the top as well, so that I know if you submit it on Canvas, I kind of know what I'm looking at. Don't forget to put your code, your name, and the math lesson. I'll see you guys back in school on Tuesday, and I'll see you in Zoom and conferences. Thank you for listening. And as always, go Ducks.